Hey folks! Okay, this time around I want to talk about blocks in Lisp. So there are a lot of places where you're only allowed to have a single instruction, a single function call in Lisp. So in the return values for an if statement, for instance, you can only have two things after your condition, and the first one's what to return if it's true, the second one's what to return if it's false. But you can't have a block of a collection of statements there. So what we want to introduce today are a couple of Lisp constructs that allow us to have blocks of things. So kind of like introducing a block in C, for instance. If you introduce an open curly bracket and a bunch of stuff in a closed curly bracket, you've got a special block of statements that are treated as kind of an individual unit. So that's what we want to do in Lisp. And we'll look at a couple of different ways to do that, one of which allows us to declare some local variables inside the block. All right, so there's three that we're going to take a look at. We're going to take a look at block, which is the simplest form, let, and let star. And there's just one tweak of a difference between the let and the let star that we'll talk about when we get there. So block essentially just allows you to take a group of statements, lump them together, and put them someplace where you would ordinarily just have one statement. The block runs through them in sequence, and then the return value from the block is whatever the value of the last statement happens to be. So, and then let and let star let you do pretty much the same thing, but you can also create local variables inside the let blocks. So we'll talk about those in just a second. Let's see, where did I want to go here? So for block, it's the usual idea. It's a function, right? It's returning the value of the last statement it runs. So it's block is the name of the function. The one unusual thing about it is that the first value in your block is generally, you'll use a symbol there, not an instruction. And so what this really is as far as the block is concerned, this is some kind of an identifier so that if at some point we want to jump to a spot within the block, we can jump to there. We'll look at how that actually works later on when we get into tag bodies and things. But for now, just take it as a given that the first thing in your block needs to be, let's say, a symbol or identifier. And then you can have a whole slew of instructions. And again, it's going to run each of them in sequence, and it's going to return the value of the last one. So for instance, if we wanted to print a prompt for the user, read what they entered, and return it, we could do that with a block. So we could have a block. I'm just going to use prompt and read, for instance, as my identifier there. We do our format statement, and we do our read. So again, it's going to print the format statement, and then it's going to read in and return whatever it was they typed in. And since that's the last instruction, that's what it's going to return. So let's take a quick look at just a bit of a play with blocks. So again, if we create a block and give some kind of an identifier, blah, and we do our format, t, print, or enter something. Maybe we'll throw in our new line there, and then we'll do a read. So it's going to run the format, wait for me to enter something, so I type in foo, and it reads the foo and returns it. Yay, woohoo. Again, if you happen to forget that identifier at the beginning, it's going to think that the first thing you give it is actually supposed to be that identifier. So in this case, if I just go block and then some statement, it's going to think that statement is the identifier, and it's not actually going to run it. So this time, it's going to just sit there and wait for me in the read. And I type in my foo. So if you're ever playing with blocks, that sounds good. If you're ever playing with blocks and it doesn't do the first thing you tell it to do, that's probably what's going on, is you've just forgotten that first statement. So blocks allow you to come up with any collection of statements, runs them in sequence, returns the value of the last one. So no big surprise there. The interesting one is with let. So let's go talk about let for a minute. Again, blocks can fit anywhere. So if you've got an if statement, you could use a block as your condition. You could use a block as the true case. You could use a block as the false case. Any place you can have a regular Lisp function call, you can have a block. So for let blocks, it's like a block, except you don't need the identifier at the beginning, and you can declare local variables. Actually, it expects you to declare local variables. So you specify a list of local variables, and the way you do it is for each local variable you want, you give a name and an initial value. So the first thing inside your let block is a list of pairs, right? Each pair is a variable name and a value. A variable name and a value, right? And then you close that list of local variables. Then after that, you start whatever instructions you want to run. So in this case, we're saying have a local variable x with a value of 5, a local variable y whose value is a string foo. We'll print out a statement saying, enter enter two items. We'll read the first thing they type in and assign it to x. We'll read the second thing they type in and assign it to y. And we'll return a list of the two things, right? So again, it's just that initial syntax of how to specify the local variables that you want. One complication. Let doesn't give you any guarantees about what order it does the variable initialization in, those local variables. So if I say something, well, if we look at that previous example, it might assign 5 to x and then assign foo to y, or it might assign foo to y and then assign 5 to x. So in a case like this, it doesn't matter, right? Who cares? The value x and y don't depend on one another in that sequence of statements. But suppose we have something like this, where we're going to do two reads. So I'm going to expect the user to enter two values. I'm going to read the first one into A, or I'm going to read one of them into A, and I'm going to read the other one into B. If we don't know which order it's going to run these two statements in, then we don't know whether the first thing the user types is going to wind up in A, or the second thing. And that's the issue with let blocks, is you have no guarantees at all what order it's going to do the variable initializations in. So I mentioned there was a let and a let star with one tweak in between, one difference in between. So the difference with the let star is it does the variable initializations in the order you give it. So if it matters to you, right, if it's important that the order happen, that the variable initialization take place in the order given, then use let star. Otherwise, use let and let the GCL figure out which is the most effective way for it to do them. So the place where this is most useful is if you want to initialize one variable based on the value of another. So if you read something into x, and if x is a number, you do something with b, and if x isn't a number, you do something else to b, right? If you actually expected a sequence of what happens here, then use let star. All right, I think that's pretty much it for our let blocks. Again, it's just a way to allow you to group different things together. And of course, where we're going to wind up using that quite often is in a function. Right? If we want to go through and let's say define a function, define x, and we'll have a couple of variables here, and I want some local variables, I'll use a let block and say, well, let's have a local variable x that I'm going to initialize to 1, and a local variable y that I'm going to initialize to 0. And then I can do a bunch of things with this. So maybe I'm going to, I don't know. Let's print you passed, tilde a, tilde %, and we'll say that's a and b. And then let's print x and y. Tilde a is x and y. Let's see, that ends my format, that ends my let, that ends my function definition, if I got that right. Yeah, well, it thinks it defined function f. So let's see if this actually works. So if I call f and I give it 10 and 20, then it should print 10 and 20 and 1 and 0. Yay! Okay, so when you've got a function and you want local variables inside the function, right? Remember, we're not using def vars inside functions, and we're not using setfs on undeclared variables inside functions, because those are sort of creating global variables. And that means if we want local variables, we're going to use a let block. So this is going to be pretty normal. All right, I will leave it there for now.